Welcome to Wales Tech Week 2021. Thank you to our partners. Enjoy the session.
Pnawn da, good afternoon everyone, welcome and thank you for joining us. I'm Manon Kynaston, Project Manager at Marine Energy Wales, and I'll be your chair for the next hour. So this is the second of 3 sessions on the Green Stage today, brought to you by Marine Energy Wales, where the industry body representing the tidal stream, tidal range, wave and floating offshore wind industries in Wales. We're delighted to be presenting you with some of the innovative technology currently being manufactured or waiting deployment in Wales. What you are about to see is the cutting edge of renewable power generation, and we take a closer look at the technological innovation that's driving forward this marine renewable energy industry, with examples from 4 technology developers looking to advance their designs and commercialise unique methods and systems for generating power from the sea. So joining us today on our steam panel is Madeline Cowley from Bombora, who are constructing their full-scale prototype mWave device in Pembroke Dock, and what will, once complete, be the most powerful wave energy converter ever built. We have Matt and Edlund from Minesto, the Anglesey-based tidal kite developer, manufacturing a unique system capable of maximising power from low-flow sites. We also have John Chapman from Marine Power Systems, a Swansea-based developer behind an integrated system for capturing both wind and wave energy. And we also have John Ma from Nova Innovation, the tidal stream developers capable of generating baseload power and currently progressing a project on the Llŷn Peninsula. So thank you everyone for joining us today. Following the presentations, we will have a short Q&A. So please feel free to submit any of your questions for our panelists during their presentations in the comment section, and we will aim to address these towards the end of our session. And please do tweet, including our Twitter handle at Marine Cymru and using the hashtag Wales Tech Week. So thank you again. Remember to add your comments and questions, and we'll hand over to Madeline Cowley from Bombora to start us off with this session.
Hello, Manon. Thank you for the introduction there. So I'd like to talk to you today about the Pembrokeshire demonstration project and the mWave technology from Bombora. I'm Madeline Cowley. I'm the project manager for the Pembrokeshire demonstration project. So to give you some highlights of the project, it's a 1.5 megawatt device that is to be tested and validated off East Pickard Bay in South Pembrokeshire in an exposed ocean environment. We have European regional development funding through the Welsh Government for the project, and we're located in the Marine Energy Test Area at East Pickard Bay. We have all consents in place, so we have a marine licence in place, and we also have some onshore infrastructure and have planning consent for that as well. And we are scheduled to install the device and start commissioning later this year. We're in the process of assembling the device, as Manon said, in Pembroke Dock at the mainstay workshops, and we have 90% of the contracts for the project awarded already. So we're currently in construction and assembly phase. So to give you some idea of the technology, I'm going to play a video next, which provides a better explanation than I can do.
Out to sea, safely beneath the ocean's waves, sits mWave. Bombora's pioneering patented technology harnesses the abundant power of the oceans to generate megawatts of clean, renewable energy. A series of air-inflated flexible rubber cells, each 15 metres in length, are mounted to a concrete foundation structure arranged to optimise energy capture. As waves pass overhead, the underwater pressure increases. mWave's rubber membranes are compressed sequentially, forcing air inside the cells into a central duct. Valves deliver a one-way airflow to the turbine, directly spinning a generator, converting this rotation into electricity. After passing through the turbine, the air is recycled to reinflate each membrane in a continuous sequence. The sustainable power generated by mWave is transferred to the electrical grid via a sub-sea cable. mWave's simple and modular design, with removable component parts, makes it efficient to operate and maintain. Its modularity makes it rapidly scalable and adaptable to both nearshore and offshore environments. Bombora, powering the blue economy with waves.
So this is the prototype that we will be installing. Just to show you some of the features of it, we have four cell modules on a steel construction. The cell modules are fitted with membranes at the top. The device sits on the seabed and is ballasted to the seabed, but whilst being keyed into the seabed through its foundation. We have two main ducts going through the central spine of the device, which directs the air towards the power takeoff unit, which houses a turbine and a generator. And then we have an umbilical from the device, which feeds the device air and communications and auxiliary power. In this demonstration project, we don't have a grid connection and therefore are not feeding power into the grid. So to show you some pictures of the fabrication, we have been fabricating the cell modules at Altrad, which is right next door to our office in Pembroke Dock, Lanyon Cove. And Altrad have now completed all four cell modules, which have been delivered to the workshop at Mainstay. And you can see in the bottom right the delivery of the cell module. So as I said, we have four cell modules that are in the final assembly phase. This is before assembly was started in this photo. These are very large structures. They're approximately 15 meters by 5 meters, and they're 70 tons fully assembled. The mWave device itself is 75 meters by 20 meters, so around about the size of a football pitch itself. Photo of the power takeoff. We have a fixed geometry turbine with a direct coupled generator. And Mainstay have been assembling the PTO, the power takeoff unit. The turbine and generator are assembled at the moment, and PTO is almost complete. This slide shows in the central picture, we have the membrane, which is attached to the cell module. This is after it had been fabricated. We have they're being supplied by HYC in Taiwan. We couldn't get membranes large enough in the UK. And then in the bottom pictures, you can see the delivery of the membranes to Pembroke Dock in rolls after being shipped over. So the schedule to completion, we are, as I said, we're due to deploy this year, and we will be testing the device for an initial period of 6 months. We are deploying the mWave in 15 meters of water. We then have a 1.4 kilometer cable from the mWave out at sea to the control station at East Pickard Bay. The cable feeds air, comms and auxiliary power. So in terms of the regional economic benefits, there's been an inward investment of £20 million to the region, and 90% of the contracts have been awarded. We have more than 80% of supply chain sourced from UK companies, and with over 50% wash content, 33% to Pembrokeshire-based companies. Pembroke Dock has a very good skills in terms of steel fabrication, and we've managed to take very good advantage of this, awarding large contracts with Mainstay Marine and Altrad. Bombora itself has grown rapidly since arriving in Wales, originally from Australia, from 4 staff to 27 staff. So offering highly skilled opportunities in the region to our staff. And half of the staff have been recruited locally, with others coming from England, Canada and Australia. And we have calculated that 45 jobs have been sustained through the supply chain contracts in Wales. So moving on to the next steps for Bombora and the technology. We have a product range of the fixed mWave, which is the device we are deploying at Pembroke in Pembrokeshire. But we've also have a floating mWave product, a floating mWave co-located with floating wind, and also an integrated mWave and floating wind product. And more recently, we have entered into a partnership with the company Technip FMC, which is a global leader in the energy industry and has a wealth of experience in marine offshore engineering, to develop an integrated floating offshore wind and mWave platform. The intention is that we would start with a demonstration of a 6 megawatt floating platform, 4 megawatt wind and 2 megawatt wave, move on to phase 1, which has a 12 megawatt installation, and then phase 2 of the project is 18 megawatts. So we're currently in the feed stage of that project, undertaking the design works. As a company, we also have expansion plans for Pembroke Dock. Pembroke Dock's well located to service offshore projects, such as European projects, Norway, Spain, Portugal, etc. And we have a planned phased expansion of assembly and export centre facilities in Pembroke Dock to service the growing pipeline. So we would be establishing an assembly and export centre within Pembroke Dock to service these future projects. And at Pembroke Dock, we would manufacture the membranes, do the module assembly and undertake system testing. And that's a quick run through of the project and Bombora and the company's plans. Thank you very much. I think you're on mute, Manon.
Thanks, Madeline. Thank you for that. And thanks for a brilliant presentation. Really exciting to see all the progress happening down in Pembroke Dock, and also just the scale of the project. We're really excited to see the deployment later this year. So I think we'll go next to Martin Edlund from Minesto for your presentation. Thanks, Martin.
Hi everyone, I hope you can hear me. I'm going to take you from South Wales to North Wales, to the beautiful Anglesey, where we are located since 2015. We are a tidal energy developer with a completely unique kite-based system. And as you may suspect, my English is a little bit Swinglish. I'm Swedish, and in Welsh and Swedish, the name kite and dragon is to some extent similar. So we call our products dragons, which I think is quite suitable given that it's all happening in Wales. We are the largest investor in a marine energy technology in Wales over the years, since 2015. And we are in our second round of collaboration with the Welsh government to combine equity from the Swedish stock market with EU-based ERDF funding, which is the basis for taking this company commercial. And the world's first commercial scale device was commissioned in Holyhead Deep, off the coast of Holyhead. I'll try to give you just a brief insight into what the technology is about. We use an advanced control system on this tethered kite attached to the seabed. And this principle in itself it's not just sort of a cool technology and an engineering challenge. It is something that really drives the inherent properties and behavior of this system is what drives competitiveness. The tidal currents that rush through the Irish Sea and brush the coast of Wales are to its nature not that high in intensity compared to hotspots around the world. And this principle we're using is a perfect match for the Welsh resource, which means that when we do the numbers roughly, we may even talk about gigawatt potential of generation that can be served from the Welsh, from North Wales, which is fantastic, I'd say. And it's about how we sweep a large cross section of the sea and use an extremely lightweight system. We talk about tens of tons per megawatt for this device that we're using. And what we do in Wales, I mean, we're located on the Swedish west coast as well, but in Wales we have the core of operations and operations development. We also lease from Crown Estate the first commercial scale site for tidal generation. So we have an agreement for lease at 10 megawatts and a potential lease area that will be able to deliver up to 80 megawatts. We have worked at this site over the years now and developed one of the world's most capable operations teams. We've also established and commissioned, I'll show you some pictures later, an assembly and service hall in the port of Holyhead, in the Stena area there, which is a key asset for further commercial development, both to build, service and develop new systems, but of course also to service the actual power generation projects and sites directly off the coast here. What you see here, the pictures of action here to the top right and bottom left, are operations from the years behind us with our own team and local suppliers involved. To the right here, you see the assembly hall from above, and some facts on the work that we're doing now. We're working on getting the 10 megawatt business case investable, and an important step is an ongoing work to deploy and commission the first megawatt plus scale device next summer at our site in Holyhead Deep. We're also working in the Faroe Islands with our Welsh team. So thanks to our Welsh team, we are operational and generating electricity to grid and have proven the second generation technologies there. We hope that our joining forces with the Welsh government will speed up grid connections and grid build out in Wales as well, which those pictures prove that we are ready for since a year back or so. It's extremely important in marine energy to do cost-effective service maintenance and installation. It's up to 2/3 of the cost structure of those projects, and that is what we're driving with our Welsh team. You see some pictures of towing principles and that we're using small vessels to get the system out to its operation location in the fjord out here. We service two markets. I talked about the utility scale device for next year, which will be really important to get that 1 megawatt device ready. We can talk about units up to 3 megawatts and perhaps 20 meters wingspan. And then also a microgrid market to serve remote locations and islands, which is important for quick commercialization of what we're doing. My final point here is that this is, even if we're creating, I mean, if we counted, it's probably 100 jobs by now with supply chains in North Wales, which is quite significant, important, of course. But this is really about energy. The tidal resource generated by the gravity from the moon is complementary to solar and wind, the more established energy sources. That complementarity resides in providing base load component generation to the grid. And those are just a few illustrations of how important it is now when we strive towards a net zero system that we add base load generation. That will reduce need for storage and technical challenges with seasonal storage, and it will reduce the overall system cost of generating electricity. And I think that's the main contribution from the Welsh tidal resource to Wales and to the UK at large, to really move towards very large scale utility build out in the Celtic or the Irish Sea. I think with that, I've given you a brief introduction to Minesto, and I'll save my comments to hopefully a fruitful discussion when we wrap this up. Thank you.
Great, thank you very much, Martin. Good to see your activity going on in Wales and the lessons that you can learn from the Faroe Islands and bring back to Wales as well. So that's great to see. Just want to remind everyone, if you do have any questions, please add them to the comment section. We really want to encourage discussion with our great panel later on. So please do add them as the presentations take place. So next we will move on to John Chapman from Marine Power Systems.
Thanks, Manon. Thanks for the introduction. So yeah, I'm John. I'm Chief Engineer of Marine Power Systems. We're a Swansea-based company. We've been in Swansea since we started in 2008. And this presentation will take you through what we're up to. I'll start with a video which will hopefully work and give you a slightly slicker view of what we're doing than me talking you through it.
The world is transitioning to renewable energy. But the oceans, the most abundant source of renewable energy on our planet, remain almost completely untapped. There's a vast amount of power available, enough to power the entire world. The only question is how to harness it. Wave sub, dual sub, and wind sub are pioneering new technologies from Marine Power Systems that will allow the vast resource of ocean waves and winds to be efficiently exploited. Wave sub exclusively harnesses the power of the waves. Wind sub enables the secure anchoring of wind turbines in deep water. And dual sub combines the capture of both wave and wind energy in a single device. All machines share a common submersible platform that allows them to be transported across the sea and installed without the need for specialist vessels. Once installed, these unique devices will deploy automatically using data on wind and wave conditions to determine the positioning for optimum energy capture. The power generated is sent to the local grid network via an undersea cable. The machines are straightforward to maintain. They can be returned to the surface and accessed for maintenance, or disconnected and transported to shore for major servicing. Wave sub, dual sub, and wind sub are highly compatible. They can be installed together in farms that maximize the use of the resources available. Wave subs and dual subs will be installed in lines that face the waves, whilst wind subs will be spaced further apart for optimal wind energy capture. This type of farm layout achieves the best possible use of marine resources, keeping ocean energy farms as compact and productive as possible, whilst producing lower cost power that's more consistent due to the dual energy sources of wind and waves. Each device has a capacity of several megawatts, with farms having a capacity of hundreds of megawatts, enough to power hundreds of thousands of homes. The ocean's waves and winds could provide 20% of global electricity by 2050. Marine power systems, unlocking the power of the oceans.
Okay, so as the video said there, our vision is to unlock the power of the oceans, and that will be by using wind power and wave power. We have 3 devices to capture the power. We have Wave Sub, which is a wave-only platform system. We have Wind Sub, which is an offshore floating wind platform, and Dual Sub, which combines the 2 into a single platform. To achieve all of these 3 devices, we have 2 proprietary technologies in-house. So we have the platform system itself, and we have the wave energy conversion system. So the advantages of our platform system, from the outset, we knew it had to be manufacturable. And so we've got a concept that can be assembled in most coastal locations with prefabrication made in a specialist site. We make sure that the devices are highly transportable, so we know we need to get them to the right locations easily and relatively quickly. And deployment likewise has to be smooth, easy. You need to do it within a weather window that's quite often quite short, so it has to be well understood and efficient. The device has to be stable. That's throughout its life, whether it's through the towing out of the system or during operation. The stability as well as safety and access ensures good power generation. The system also needs to be maintainable. We achieve this by having the above surface access points. For example, if a small fuse fails in the system, we don't have to bring the whole device up out of the water. We can send someone out to fix it on site. And the system also has to be survivable. Storm waves in the ocean are orders of magnitude higher loads than the energy waves that we're targeting. And so you have to either be able to withstand that load, which usually ends up in excessive cost, or you need to have smart ways of getting out of that wave. And that's what we do. So why are we doing it? Hopefully nobody needs convincing of the climate agenda, that we know we need to reduce our carbon output. And so renewable energy is a strong driver from that point of view. But there's also a commercial goal. There's a huge global demand. And together with floating wind and wave and the combined, there's also potential for huge global supply. You can see in the top 2 images that the supply matches well with where the people are using the energy as well. So the whole coast of Europe, the west coast of the USA, and then going down into the southern hemisphere, South Australia, South America and South Africa, all with very good resources of wave, and wind is really a global resource that we can tap. So onto the platform system itself. The performance of this, we've had an independent study looking into all of the different types of floating platform that people are looking at for wind energy, but also for wave. And that survey came back that our structure has the potential to be the lowest structure mass, which equates to cost of the system. It also has a very good stability, which leads to generation and accessibility benefits. And it has a small mooring footprint, which saves for installation complexity, but also involves a lower environmental impact. So you can imagine some of these systems have long lengths of chain dragging along the seabed, and that scour on the seabed is quite an ecological impact that we avoid with our system. And then onto the wave energy system. So the key advantages here are we interact with the orbital path of the wave. So you can see the small particle motion moving round in the orbital path there. That is how the energy flows in a wave. And so to capture the energy, you need to be able to interact in those directions. If you can only interact in one direction, you're effectively throwing away the energy before you've even got to the conversion device. We also know we need to be tunable to commonly occurring sea states. So the top rated power is not necessarily what matters, it's how consistent that power is. And so you need to get a good power supply throughout the commonly occurring waves of the system. And to do that, we ensure that tunability, and that gives us the high annual yields that we need. And then, as mentioned earlier, when those storms come, you either need to withstand them or get out of their way. And we have a system to avoid that storm loading. We dock the absorbers down onto the system, and in that way they duck out of the worst loading of those storm waves. A little more then on the wave energy performance. So we have a power takeoff system that's able to control the force interaction with those floats and optimize the performance of the system. In small waves, we can increase our power capture, and in large waves where there's excessive energy available, we can detune ourselves but carry on operating until we get to very large storm waves, in which case we can shut down and avoid those loads. You can see from the chart there, this is a power plot, so we get those high headline figures of the maximum power. But what's also important is that we get a smooth spread of the power generation that can contribute throughout most of the year and give a high energy capacity, not just power capacity. So what have we done already? We've had a device out in Cornwall where our testing is completed on this now of our medium scale sea testing. Within that test, we were able to demonstrate the transportability of our device, towing from our manufacturing site in Milford Haven down to Cornwall. And then we've demonstrated maintenance of the system at sea, and also the important one there that we've proven we can generate grid compliant power. And what's next for us? Well, we're currently working on the full scale demonstration device. So this will be approximately 0.5 megawatt single absorber to demonstrate the wave energy system, and an approximately 2 megawatt wind turbine. We'll be starting manufacture late this year or early next, and the testing will happen towards the end of 2022 or early 2023. So thanks all for listening. I hope you enjoyed that and it gave you a bit of a flavour for what we're doing. But if you're interested, please do follow us on social media or on our website. We've got lots going on at the moment. There's current vacancies if you're interested, and we're also currently crowdfunding. So thank you very much for listening. I'll hand back to Manon.
Thanks, John. That's great to see, and good video at the start to make it really visual as well. And good luck with all your work on the co-location in Wales and further afield as well. So just another plea really to get your comments and questions into the comment section. We've got quite a few lined up for Matt and Edlund, but if you've got any for our other panelists, that would be great. So we'll hand over to our last panelist before the Q&A, and that's John Marr from Nova Innovation. Oh, you're in mute, John.
Hello. Thank you for letting me know I'm on mute. Nice to see you all. Thank you very much. I'll just share my presentation. 1 second. Okay, I think you can see that. Is that okay, Manon?
If you just go into full screen, yeah, perfect.
Great. Okay, well, first of all, thank you very much for the opportunity to speak at Wales Tech Week. I'm just going to run through some slides and tell you all about Nova Innovation, Tidal Energy, and our Blue Energy Islands. So first of all, in Wales, we have a fantastic project right at the end of the Llŷn Peninsula, Ynys Enlli, or Bardsley Island in English. And there it is before you. You see our turbine there sitting on the seabed below the surface of the water, so it's invisible, has no visual impact, which helps with consenting, which is a big advantage for tidal energy over other types like nuclear or coal-fired power generation, or even wind or solar. So it basically, what it is, it works as, it's like an underwater wind turbine. Only instead of using the power of the air, it uses the power of the sea. And as Martin mentioned, I think it was in his presentation, water is 800 times denser than air, so you get a lot more punch, a lot more power for a smaller device. Just to kind of touch on some of the visual impacts. So this is a photograph of our tidal powered array in Shetland in Scotland. This is the home of the world's first offshore tidal array. And you know, the strapline there is Spot the Power Station. So the great advantage you have with tidal is that it doesn't mar the landscape. So it's clean, it's predictable, there's no visual impact, there's no navigational hazard, so ships can continue to sail uninterrupted above the turbines. Our turbines can continue to operate during storms, and they're also environmentally friendly. So there are no dams, barriers, and it doesn't have a it doesn't interfere with marine wildlife. I'm just going to show you a picture of a video. This is actually going to show you a video. This is what we released earlier this year, and in Shetland we actually have tidal powered cars. So we've installed a EV charging point at our tidal powered array, and this will give you a flavour of what that looks like. Just 1 second. Great. I hope that kind of gives you a glimpse there of the future with the whole push towards net carbon zero, and the sort of banning of new diesel and petrol vehicles from 2030 onwards. We really are going to need to use new sources of clean energy. And the great thing about marine power is that it's complementary with wind and solar. We're not going to be able to meet our wind and solar targets alone, and we need new sources of energy. And the great thing with the tide is it's predictable as well. So just in terms of a little bit more detail on our turbines. So here is a turbine. This has actually been installed in the waters in Shetland. This was it's sort of dry side mating test before it's installed on the seabed. And the great thing about our technology is that we've been running them for more than 5 years. So they've been powering homes and businesses in Shetland for a long time, and we're now powering electric vehicles as well. As well as the actual cost of developing the technology, we look at the full life of the devices, and so it's important that we can have low-cost vessels to install and also maintain the turbines during the life. We have also the added benefit of our technology being scalable, so these turbines can deploy as single devices or in multiples to produce megawatt arrays, and we've had a lot of technical innovation. So just to give you some example, our strategy is all about starting small before scaling up, because that way you are really making the most of your product development. It kind of makes it most cost effective, and it accelerates the innovation as well. So as an example of that, so this turbine here, it has a direct drive, so there's simply a set of blades and a direct drive generator. Our earlier turbines actually had a set of blades, a gearbox and a generator. And by removing the gearbox, we have fewer moving parts, which improves reliability, and critically it also extends the service interval between maintenance, so going from 1 year to 2 years plus. So just some examples of where we're either installed or are about to install the technology. So the first array is up in Scotland, and that is powering the Isle of Yell, which is just up Blue Moor Sound. We have 4 turbines installed, and we'll be adding 2 more turbines next year. The next project in the pipeline is Canada, so that's currently under construction, and that's in going to be powering Long Island, which is just in Nova Scotia near Halifax. That's with 15 turbines, and the first turbine is due to be operational later this year. And then we also have Ynys Enlli in North Wales, in Bartis Sound. That's for 5 turbines, and we'll have first power from that in 2022. In terms of one of the key themes at the moment in life is sustainability, and it's really just important to kind of recognize the benefits which marine energy is bringing to society. So if we look at the environmental aspect, we've got the climate emergency, we've got the landscape and the marine wildlife, and here there's clearly a source of clean energy which is really helping to reduce carbon emissions. We think about society, it's obviously going to improve health, and it sort of ties in very well with the UN sustainability goals. And then the third dimension is economic. I think countries around the world are recognizing the need for a green industrial revolution and the need to build back better. And the UK is in a great position in Wales and Scotland where it's leading the world, and there's a huge economic growth and potential for jobs, for industry, for manufacturing, and really just kind of helping to rejuvenate coastal communities and populations around the world. So First Minister Mark Drakeford summed this up brilliantly when he said, investing in marine energy makes economic sense, environmental sense, and will help stabilize a bright and healthy future for our future generations. So on that note, I'll end, but I look forward to hearing any questions and discussing that with the panel shortly. Thank you very much.
Great, thank you very much, John. I think we'll invite the rest of the panelists back if we can. Perfect, that's great. Just another thank you to all our panelists for your really interesting and engaging presentations, really visual. It's great to see all the progress taking place. So you've all demonstrated the key role that this innovative and growing industry can play a key role. You've mentioned a predictable, diverse energy mix, economic benefits to our coastal communities, increasing inward investment to Wales, and the export potential as well. And a key aspect of that, I suppose, is gaining public and political support. And I was just wondering, just to start off, could we just go around the panel to hear more about what your company and your business is doing to increase that public awareness and public support for your project, but for the sector as a whole, and what we can do to kind of develop those skills and awareness of the sector in Wales? So I might go to Martin first. Okay.
I think the most important factor is to show real industrial progress. And I mean, we're still operating at a fairly small scale compared to where we're headed. So I mean, it's really to keep focus on the industrial rollout of what we're doing, and that will draw a lot of attention to it automatically. So in the meanwhile, I mean, it's taking part in the local community. It's working with schools, apprenticeships, your local supply chain, get out of the pandemic situation so we can have an inauguration of our assembly hall. All those aspects, taking part in events like this. And then, of course, keep working together with the strong backers we have, both in the Welsh government and in the public sector in Wales. I mean, that's why we're all here, all of us, I think, because there is a belief that this will really be the breakthrough location in the world for marine energy. So that's briefly what we think.
Great, thanks, Martin. Go on to Madeline.
Well, echoing what Martin said, obviously getting projects in the water does demonstrate that the technology works, gives you results, gives confidence in the technology. We've also, in terms of our supply chain, we tend to get a lot of enthusiasm from our suppliers, and our suppliers are in the local area. People are always very interested in the project and want to learn more about it. So we find that quite a good way of just getting interest locally. I would say as well, in terms of the consenting process, we held public exhibitions, and we didn't have issues come up as a result of the consultation. It's a benign technology, as is also spot the wave energy device. You can't see it from above the water. So yeah, just demonstration is going to get the support and get the provide the information to for the political support as well.
Great, thanks, Madeline. John, you mentioned a few projects that you've got in Scotland already around the whisky distillery and other projects that you've got with the essentially aspects. Can you give some examples of what Nova's doing to increase that public awareness as well?
Sure, of course, yes. Well, I think doing what we do is very novel, and I think it naturally attracts media interest. So we've been very fortunate to be featured, on the BBC websites and the various broadsheets, the likes of the Times, the Telegraph, local newspapers, national newspapers, international press as well. And I think it's kind of it really feels over the past 18 months it's really started to scale up, and I think that's kind of tied in with the whole realization that climate change is an extremely real issue. The climate emergency has kind of been escalated. There's been a huge drive towards sustainability, and even the setting of the net carbon zero target. So it's all becoming a lot more real, and so people want to see how we are going to diversify away from fossil fuels. And I think obviously solar and wind are established, and that's great, but we do need new sources of clean energy, and that's where really kind of marine energy can step into the fold. And as an example, on the back of announcing funding from the Welsh Government for our Kynaston project in November, we actually featured on the BBC children's television programme Newsround. You guys will probably remember John Craven from when we watched it as children, and I think John's moved on and it's now a much younger presenter. But that was great. We've also featured done a piece on ITV news piece. And then at the end of May there, so less than a month ago, we featured on Countryfile. And we were kind of the headpiece, and there was a sort of 10-minute section really just talking about the massive potential for tidal energy in Wales and in and around Kynaston to help to rejuvenate coastal communities and deliver a more reliable source of power to grids. So I think quite often you have communities right at the end of the grid lines. And I think as well as developing tidal energy, there's huge scope for microgrids, and we have solutions. So it's great. You know, it's really, really good. So yeah, great television coverage, and it really feels as if it's just the beginning, and there's a lot more potential, which will emerge as the technology matures, as the industry grows and becomes more international. And as I sort of alluded to in the presentation, we're currently working on our first export project for 15 turbines in Canada. That'll be the world's largest array by number of turbines installed when it's fully operational, and we see that as a flagship project where we can then start to sell turbines into other parts of Canada, the United States, all across Asia. So that really the potential is huge.
Great, thanks, John. Like that, making marine mainstream sounds good. I will pass on to John. Right.
Thanks. Yeah, so a similar theme, I think, from us as the everyone else there, that it's really about bringing people along on the journey, making sure they're as excited as we are about the opportunities and the potential. And one of the best ways of doing that is by showing it actually working. It is exciting stuff out at sea, but it is out at sea, so you don't see it unless you share. And we use social media to do that, but also schools engagement. And I think the crowdfunding rounds as well is a good way of actually making people physically connect with the systems. They actually have a sort of vested interest then. And so we found a lot of enthusiasm through that route as well.
Perfect, thanks, John. And yeah, we've got our own MEW education programme that you can find out more about on our website. And I know a lot of the companies around the panel have been helping us with the schools engagements and trips, just to show what is going on with these devices to our school pupils and college students as well. So that's been great. So we'll go to a question that's come in on the comments. So this is for the whole panel. How will the LCOE, so the levelized cost of energy, be evolved over time with your project or device? Will it be compatible with offshore wind? We'll start with John Chapman.
Okay, so yeah, we have the suite of products, and we've predicted the cost of energy for all three of those. And given the right sites, so obviously if you put a wave energy device where there aren't waves, it's not going to be profitable. But given the right sites, all three of those devices, we've shown a trajectory where we reach competitiveness with fixed offshore wind, so the current system. And the confidence we have there is that we've been able to look across at the other systems developing floating offshore wind, and we can see the trajectories of them are comparable, and we can see where our predictions match theirs or where they differ. We can see it's due to our prediction, so we're confident we can match that low cost of energy.
Thanks, John. We'll go to Madeline, please.
Yeah, I mean, similarly, our predictions are that we can compete with offshore wind. The co-location and integrated option obviously does sort of add to the energy density of the offshore wind farm site. We have a bit of a way to go at the moment. We're just on our first project, first installation. We are currently designing the integrated option, but yeah, the projections are that we can compete.
Perfect. And we'll go to Martin.
Yeah, Minesto's deep green technology, climbing on a steep learning curve, will outcompete offshore wind within 200 to 300 megawatts of installed capacity. And on top of that, we're generating continuously, and peak winds will drop prices. So an overcapacity of wind will be really bad for the taxpayers and for the whole energy system. So I think there are enormous arguments in favor of tidal energy, actually, to reduce costs for the taxpayers in the end, and to get really competitive new technology-based companies in Wales.
Thanks, Martin. We'll go to John Ma.
Thanks, Manon. Yes, no, it's a good question, and I think some context here is required. So wind is a very mature technology. It's kind of been really kicked off in the 80s, and costs were very high initially, and it's come down the cost curve as the industry has matured, as the capacity installed has increased, and as the learning has been applied. And you see the similar trend in other technologies. You see the similar in solar as well. Costs have come down rapidly. And even offshore wind, 2 years ago, it was, I think the strike price was £140 per megawatt hour. So it's about understanding that, and I think the other context is actually, it's not just about being the cheapest source of power, it's about being competitive with the marginal source of supply. So, for example, there are lots of islands across the world which are burning diesel, which is very expensive. It's also very noisy, and it's also very polluting. And the costs there are kind of upwards of £400 or £500 per megawatt hour. So it's about understanding that dynamic. Now, in terms of tidal, so we are, Nova's already competitive with diesel generation. We are displacing diesel generation in Shetland, and we've proven it can be done. And we're now focused on driving down those costs, and that's what we're doing through our innovation. And just to give you some context there, the EU has set a target of for tidal energy reaching €150 per megawatt hour by 2025 and €100 per megawatt hour by 2030. And we are well on track to achieving that. So that hopefully, Frederick, that gives you some context in terms of figures and the direction of travel in really bringing those costs down. And so the 2030 figure is significant because at that stage we'll be cheaper than nuclear power, which is really, really massive.
Perfect. Thanks, John. So yeah, thank you to all our panelists. So we're just coming to the end of the session now. It's been great to see just all the diversity of the technology innovation taking place in the sector from tidal stream and wave energy across Wales. So before we close, just want to flag that our next session on the green stage will take place at 3 o'clock. So about half an hour, and before that one takes place on marine renewable supply chain innovation. If you would like to sign up to the Marine Energy Wales newsletter, you can do that with a little link in the comments that my colleague will put up shortly. That will help you to stay up to date on the Welsh marine renewable activity in Wales, but also of our members, which the 4 companies are a part of as well. You can also follow us on LinkedIn and on Twitter at Marine Cymru as well. So once again, thank you everyone that have joined us today as attendees, for including your comments in the chat, and also to all our panelists from the companies in Wales. Diolch yn fawr, thank you again.
Thank you for watching. Rewatch all of our sessions online. Thank you to our partners.